Hello, this is Ms. DB, and in this lesson we're going to learn about properties of logarithms. This is from Chapter 7, Section 4. Our objectives are to use properties to simplify log expressions and to translate between logs in any base. At the beginning of the start of quarter 3, we reviewed properties of exponents. And that was good because remember that logs are exponents, so you're going to realize that the properties are very similar. The log function for pH that you saw in the previous lessons, pH equals negative log of the h plus, can also be found or can also be expressed in exponential form, like 10 to the negative pH, because remember this is log base 10 if there's no base there, equals h plus. That is because of our definition of log, which is that b, the base to the exponent, is equal to a, can be written as log base b of a is equal to x, the exponent. So again, because logs are exponents, you can derive the properties of logarithms from the properties of exponents. Our first one is going to be based off of when we multiply powers with the same base, you add the exponents. Here's an example with numbers. If we had 3 to the second times 3 to the fifth, you could write that as 3 to the seventh. So 2 plus 5 is equal to 7. With logarithms, we call the product property of logarithms this. The log of a product is equal to the sum of the logarithms of its factors. Here's an example with numbers. Log base 3 of 1,000 is equal to log base 3 of 10 times 100 because 10 times 100 is equal to 1,000. Therefore, we can rewrite this now as log base 3 of 10 plus log base 3 of 100. So if you know there's a product that you are taking the log of, you can rewrite it as the sum of those two separate logs. With algebra, with variables, we would write it like this. Log base b of mn is equal to log base b of m plus log base b of n. So again, if you can break a number into its factors, then it's equal to the log base b of both of those factors added together. We can also do this in reverse. So it might help you to think about a log jam. It works like this. Log base j plus log base a plus log base m is equal to log of jam. So you can multiply the bases together. Let's look at this example. Log base 6 of 4 plus log base 6 of 9. These are the same base, and we are able to write that as a single logarithm by multiplying the 4 and the 9 together. We do not multiply the 6 and the 6. We just multiply right here. And then you would get 4 times 9 is 36. So this is equal to log base 6 of 36. And then we are asked to find what the log base 6 of 36 is equal to. So it's saying, what is this equal to? And remember that the way you find that is looking for the exponent. So they're saying 6 of what is equal to 36, rewriting it in exponential form, just like they said over here. And then you'll find the exponent. 6 squared is equal to 36. So sometimes you can simplify, sometimes you can't. Let's look at this example. Log base 5 of 625 plus log base 5 of 25. So we know that they have the same base, and we know that we can use the product property to multiply the 625 and the 25 together, which is a really big number. 15,625. Now, we maybe can try to simplify this. Let's see if we can. If we can, it would mean the base of 5 to some exponent is equal to 15,625. Now, you might want to get your calculator out. I know that 5 squared is 25. I know that 5 cubed is 125. And I know that 5 to the fourth is 625, because 25 times 25 is 625. That's as much as I know that I have memorized. So get your calculator and find out what 5 to the 5th is, and 5 to the 6th, and then you'll find that 5 to the 6th is 15,625. So the answer to this is 6. All right, some of these we can simplify again, and some of them we can't. These are the problems from your worksheet. Oops. So let's look at number 5. That one looks interesting. We're going to take log base 3 of 6 plus log base 3 of 13.5. So we want to first use our product property to rewrite this as log base 3 of 6 times 13.5. So I need to multiply this. If you have a calculator handy, you can do that. Check my multiplication. 18 plus 3 is 19, 20, 21. 6 times 1 is 6, plus 2 more is 8. And I need to move over 1 decimal point. So 13.5 times 6 is 81. So this is log base 3 of 81. Now, I want to see if I can, this is an answer, but I want to see if I can write that and find its exponent. So that means that I would have a base of 3 to what power is equal to 81? So 3 squared is 9, 3 cubed is 27, 3 times 3 times 3, and 3 to the 4th is 81. So that means 3 to the 4th is equal to 81, so the answer to this is just equal to 4, because when you're looking for a log, you're looking for the exponent. So that one was able to be simplified. And that's pretty much it for those. They're not too tricky. Sometimes it's a little bit tricky to find the exponent that they simplify to, and sometimes you can't. There might be some of these that you're not able to simplify. Here's just another example with fractions. There's none of these on your worksheet, but I thought it'd be good to look at that. They're not really that bad, especially because when we multiply these using the product property, 27 times 1/9 is just 3. So we're looking for log of base 1/3 of 3 is equal to what exponent? So we write 1/3 to the what power is equal to 3, and that would be -1. So even though it looks like it's going to be tricky, it's really not. All right, here's another property. Remember that when we were dividing powers that have the same base, you subtract the exponents. Again, they have to have the same base. Here's an example. If we had 10 to the 8th over 10 to the 3rd power, that would be the same as 10 to the 5th power. Sometimes when you do this, you get negative exponents when you're working with exponents. Like what if you had 10 to the 4th over 10 to the 11th? Then you would have 10 to the -7th for your exponent. When we're talking about logs, it's very similar to what we just did. It's the same as finding logs of the quotient with that base. Here's how it works. In algebra, we would have log base b of m over n is equal to log base b of m minus log base b of n. That's how we'll see it most often. With numbers, if we had log base 5 of 16 over 2, that's equal to log base 5 of 16 minus the log base 5 of 2. It also works in the opposite order. If you were subtracting, you could rewrite that as a quotient. Remember that they have to have the same base in order to be simplified. All right, let's look at this example. This one is written as subtraction. We can write this as a single log by combining that using the quotient rule. So this could be rewritten as 100 over 4 or 100 divided by 4, which is 25. Now, some of these, again, you can simplify because we can rethink about this as 5 to the what power equals 25. We're looking for the exponent, and the answer to that would be 2 because 5 squared is 25. All right, again, let's write this as a single log. So the quotient rule says that you can divide the 49 and the 7. Don't subtract them and get 42. Divide them and get 7. So this is the same as log base 7 of 7. This was a property we learned when we first learned about logs. If you have the same base as the number, it's always going to be equal to 1. 7 to the 1 power equals 7. So the answer to this is 1. All right, on your worksheet, you're going to do the same thing. You're going to express as a single log and then simplify if possible. Let's look at number 12. Log base 6 of 180 minus log base 6 of 5. So we can use our quotient rule to rewrite this as 180 divided by 5, or 180 divided by 5 if you prefer. And then we are going to find out what that simplifies to. So 180 divided by 5, that goes in there 3 times, and 6. So 36. So this is the same as log base 6 of 36. And we're looking for what exponent would that be. So 6 to the what power is equal to 36, and of course 6 squared is. So this is equal to 2. And the rest of those will be done the same way. We can also take powers of logarithms. The logarithm of a power is the product of the exponent and the logarithm of the base. So in numbers, if you have the log, this is, remember, base 10, of 10 to the third power, you would put the 3 in front and be multiplying by the log of 10, log base 10 of 10. In algebra with variables, log base b of a to the p, you can put the p in front and then multiply. So for a here, the 6 will come in the front, and then it'll be 6 times log base 2 of 32. And then you will see if you can simplify this part. So log base 2 of 32 is 2 to the 5th equals 32. So this part all simplifies to 5. And then you can take 6 times 5 equals 30. So the 6, you just hold on to it for a second while you figure out if you can simplify this, and then you multiply. B will be similar. The 20 will come in front, and it'll be 20 times log base 8 of 4. And then you try to see if you can figure out this part. If you can, that means that you have 8 to some power is equal to 4. Well, 8 to the 1 is 8. 8 to the 0 is 1. 8 to the 0 is 1. 8 to the negative 1 is 1/8. 4 is somewhere in here, but I don't know exactly what it is. This one cannot be simplified, and you would just leave your answer like this, 20 times log base 8 of 4. Now, they went ahead and found the fractional exponent that this would be, but you don't have to do that. You can leave your answer right here. Okay, let's see if we can simplify these. In A, you would multiply 4 times log of 10. Now this, remember, is called the natural log when you don't, or the common log, when you don't have any base listed, it's a base of 10. And the log base 10 of 10 is 1. If you have the same base as the number you're taking the log of, then that's just 1. B can be simplified as well, because 5 to the what power is equal to 25? That's 2. So the 2 for this goes in front. So we have 2 log base 5 of 25, but this part here is equal to 2. So then we have 2 times 2 is equal to 4. One more example with some fractions to see what this would look like. The 5 would be in front, so we'd have 5 times log base 2 of 1/2. Now don't assume that because it's a fraction it's going to be really tricky. We're really saying 1/2 to what power, or sorry, 2 is the base. 2 to what power is equal to 1/2. Remember, 2 to the 1 is 2. 2 to the 0 is 1. 2 to the negative 1 is when you drop it down and you'd have 1/2. So that's exactly what you'd get. You'd get negative 1 for your power. So 5 times negative 1 is negative 5. And we're going to wait to do the problems on the on your worksheet until after we've learned the next part as well. Exponential and log functions undo each other since they're inverse operations. We already learned about that. For any base b such that b is greater than 0 and b is not equal to 1, you can take log base b of b to the x would be equal to x. So why would this be true? You're just undoing it. We know that the base to the exponent is equal to this part. It's the same thing. This would be undoes itself. And same thing here. If this is our exponent and we wanted to write this in log form, we would have log base b of x equals the exponent of log base b to the x. It's the same thing on both sides. So they're just undoing each other. With numbers, if you have log base 10 of 10 to the 7th, that's just equal to 7. If you have 10 to the, this is an exponent, log base 10 of 2, that will be equal to 2. So if you can remember these inverse properties, it'll make solving your problems even easier. Let's look at some examples when we would have this happen. Here we have log base 3 of 3 to the 11th. Now, if you didn't recognize it, you could work it out. You could say, oh, okay, I'm going to use that power property that says I can take 11 times log base 3 of 3. And then I would have to figure out what is the log base 3 of 3. Oh, that's 1, so 11 times 1 is equal to 11. Or you can say, wait, this is an inverse. I'm just undoing. When I take log base 3 of 3 to the 11th, these parts are just undoing, and I'm just going to get 11 for an answer. See the 3's and the 3's here? Log base 3 of 81. It doesn't look like it's an inverse situation yet, but what if we rewrote 81 as 3 to the 4th power? Now we see that 3 to the 4th power, and here we have log base 3. So there's the 3's and the 3's again. It's just going to be 4. So if you can recognize that you have an inverse, it makes your problem really quick. You can just instantly look at it and find what the answer is. Here we have 5 as our base, and this is our exponent, the log base 5 of 10. Now you could rewrite this, but you could also say, wait, this is the exponent situation. I've got the base here, the same as the base in my exponent. So then that's going to just be equal to 10. Here's just a couple more examples using the same thing. Remember that the common log has a base of 10, so here we have the 10s matching up again. So the answer to this will just be 0.9. And here we have the 2 as our base of our exponential form, and also 2 as the base in our log that is the exponent. So this is also an inverse situation, and the answer will just be 8x. All right, so here's the problems from your worksheet that are a mixture of the last couple examples that we looked at. Some of them, like number 13, are already set up to be inverses, actually quite a few of these. And some of them, like number 18, is where you would take, that's the exponent is 4. It's kind of funny looking, but you would write the 4 in the front times log base 3 of 9. And then we simplify this part, so we're really saying 3 is our base to the what exponent is equal to 9, and that would be 2. So we'll have 4 from this 4 times, this all simplifies to 2, and then you get your answer of 8. For number 7, this is 7 raised to the log base 7 of 30. This matches this, so you can use the inverse to just say that this will be equal to 30. A lot of these are working that way. Let's do number 17. For this one, let's put the 5 in front using the property log base 8 of 8. And you'll see that the log base 8 of 8 is equal to 1, because 8 to the what power is equal to 8? It's just 1. So even if you don't recognize that this is an inverse, you can still do the problem using the properties and you'll get the same answer. So those are actually kind of fun to do. All right, last thing that we need to talk about today is the change of base formula, and I've talked about this leading up to this in previous lessons, that unless you have log base 10, or we're going to learn another one, then your calculator can't handle it. So we need to be able to find a way to change our base, or to change the way it's set up so that we can use our calculator to help us out. All right, so here's how it works. If you have a base of b and you don't want that base anymore, you can take the log of any base times x over the log of that same number of b. Now, why would you want to do it? You'd want to do it to change it to base 10. So they changed theirs to base 2. You can use any number here. We almost always would be doing this to change it to log base 10 so that we could use our calculator to finish the problem. Like if it's not one that you can do in your head. So in this one, I would not use base 2, I'd use base 10. So I change this to log base 10 of 8 over log base 10 of the original base that I had. And this I can do on my calculator now, because if you just type in log of 8 divided by log of 4, you would get a decimal number that would be the answer to this problem. So usually we change it to base 10. So here's an example where we are changing log base 32 of 8. And remember that when you use base 10, you don't actually have to write the base 10. So that's nice too for typing. You don't have to use that little subscript button. So log base 32 of 8 would be changed to log of 8 over log of 32. These are both base 10, but you don't have to write the base 10. Then you can get your calculator out and you can figure out what is the log of 8, what is the log of 32, and then you can divide them. Now, do not round this to the nearest even tenth. Write out as many numbers as you can, or even better, leave it saved on your calculator, then divide by, then figure out log of 32 before you get your answer. Let's see what they get. They got 0.6, and they use those little squiggly things to mean it's about that. I'm going to show you on the computer calculator how to do this. Now you might have a handheld that works slightly different, and that's all right. All right, so I'm going to take, now on your, if you have a handheld calculator, you probably push log first and then the number. I have to take 8 and then log. So this is the log of 8. Now see, it's not really 0.903, it's really 0.903089, and go on and on and on and on. I'm going to divide this by, I'm going to put some parentheses to make sure this handles it correctly. The log of 32. And again, on the calculator one, I have to hit 32 and then the log button. And then I close my parentheses. So here's the 1.51 that they rounded to, but really look at all those digits. And now I'm going to hit my equal sign, and let's see how close it is to 0.6. Oh my gosh, it's exactly 0.6. So mine was not rounded at all, and I got 0.6. So that is unusual for that to happen. There's that problem finished off, which I think maybe tells us that we could have simplified that one in our head if possible. All right, so let's, this is another method. They're saying you could change it to base 2 because both 32 and 8 are powers of 32. Oh, so they recognize that 8 would be 2 cubed and 32 is 2 to the 5th or 2 to the 6th. Oh yeah, it's log base 2 of 8 is 2 cubed. So that means log base 2 of 2 cubed, that would just be 3 because you can use your inverse there. And log base 2 of 2 to the 5th, here again it's the inverse, would just be 5. And 3/5 is exactly 0.6. So it's the exact same thing as we got on the previous page. Okay, let's do this one as base 10. So log of 27 over log of 9. So this base is what goes down on the denominator. The top would be the log of this number. So that's pretty easy. Then you can use a calculator. Again, do it the same way I showed you before, where you try to hold as much in the calculator as possible. That will give you a much more exact answer. And they got 1.5. And then, or you could say, I'm going to rewrite these as log of 3 to the 3 cubed and log base 3 of 3 squared. So that equals 3/2, which is the same as 1.5. Sometimes, now we use the change of base formula generally because they can't be simplified any other way. They're giving us some problems that could have been simplified a different way. Such as this one, you'd get 1.3. All right, so on your worksheet, these are not necessarily ones that could be simplified another way. Maybe they are, maybe they aren't, so it just kind of depends. Let's look at number 23. We're going to use the change of base formula to write this as the log base 10, if you want to write that you can, of 10 over the log base 10 of 5. But it's easier to just write this as log of 10 over log of 5. And then you can get your calculator out and figure out what is, where's my calculator, what is the log of 10. So again, on mine I have to type in the 10. This one you might have guessed what it was. It's 1. Divided by log of 5. Put my parentheses is equal to this. So 1.4, it's about what, if you're going to round to the nearest tenths, hundreds, thousands, you'd have 1.431. Let's do it that way. It was 1.431. So round these to the 3 decimal points or to the nearest thousandths place. And that's it. Let me know if you have any questions. If you get stuck on any of these, just send me an email and I'll help you out. Have a wonderful day, and thank you very much.